I am Larry Hetcher. This is Psych 302, Computer Applications in Data Analysis. And with this video, we're going to look at part 2 of my two-part series on Chapter 120, ANOVA with one within subject factor. My usual warning to my students, Psych 302 students, remember, you don't need to download the data set or do any of the analyses described in these notes. Instead, just use these lecture notes as a guide when you complete your exercise, which will involve a different data set. You'll recall from last week that this chapter is divided into class meetings. We covered pages 1 through 25 during our initial class meeting, and we're going to do pages 25 through 39 during this second class meeting. So let's scroll down to page 25 and see where we left off last time. Okay, I'm at the bottom of page 25 and we have this note. Now, last week we went over the first 25 pages of the set of lecture notes, and we see this red font note that says begin work on Jamovi exercise 120.01 ANOVA one within factor. For today, you'll complete only task 1, performing the analysis in Jamovi. You don't need to complete task 2 and task 3 until next week's class meeting. You don't need to upload anything or do the quiz today. Now, that was last week. This week, you do need to worry about these things. This week, you are going to do task 2 and task 3 of the exercise, and that will involve making sure you understand the output, taking the multiple choice quiz that will quiz you on interpreting the output, and you'll upload your Jamovi program that you created last week when you did the analysis. So that's the exercise. That's what's coming. But to be ready for the exercise, we're going to go over these lecture notes and see just how one makes sense of the results of that analysis. Interpreting results from the analysis. Let's scroll down to page 26. I thought rather than going back to the beginning of the set of lecture notes and going over the description of the study, it would be better to just begin on page 26. Begin on page 26 with this section, General Trend of the Results. Our research hypothesis presented earlier predicted that screen size would be positively related to reading enjoyment. Larger the screen, the greater the reading enjoyment. Therefore, our first step will be to review the mean reading enjoyment scores obtained under the 3 treatment conditions. Those means are illustrated graphically in an error bar plot that's reproduced below. Last week, we talked about an experiment in which you were interested in comparing e-readers, similar to the Nook or to the Kindle that can be used to read books, textbooks, magazines, and such. Specifically, you wanted to find out whether the size of the screen would have any effect on the reading enjoyment displayed by the people who were using it. So you conducted an experiment in which people spent 2 weeks with screens of various sizes. Now, at the end of a given 2-week period, you had them complete a scale in which they rated their reading enjoyment. Scores could range from 1 to 100. 100 means higher levels of reading enjoyment. You conducted a true experiment in which there were 3 treatment conditions. Your independent variable was screen size, and 3 conditions was 6-inch screen versus 10-inch screen versus 12-inch screen. Now, this was a within subjects research design, a repeated measures research design. You had a group of participants, and you exposed a given participant to all 3 of these treatment conditions. They spent 2 weeks working with the e-reader that had a 6-inch screen. At the end of the 2-week period, you had them rate their reading enjoyment. The same participant then used an e-reader with a 10-inch screen, and at the end of that 2-week period, you have them give a rating of how much they enjoyed using the 10-inch screen. And then at a different point in time, the same participant spent 2 weeks with a 12-inch screen, and at the end of that 2-week period, they rated how much they enjoyed the 12-inch screen. As I'm saying this, I'm getting to wonder, was it a 2-week period, or am I confusing this with another study? let's go back to the beginning. I hate to spend an entire video describing a study incorrectly. 10 college students, one point in time. Yeah, they spent 2 weeks with the tennis screen. So you've got 10 college students, and a given college student will spend two weeks with the 10-inch screen, 2 weeks with the 6-inch screen, 2 weeks with the 12-inch screen. At the end of a given 2-week period, they provide a rating indicating to what extent they enjoyed that reading experience. Now, I am now back where it was a second ago. Page 26. We're looking at the general trend of the results. This is the figure I showed a minute ago. Well, what do we have? It looks like the people had the highest level of reading enjoyment when they used the 12-inch screen. The circle in the middle of this error bar represents the mean score. We can see that the mean for the 12-inch condition is a little bit higher than the mean for the 10-inch condition. Don't know whether there's going to be a significant difference between those two groups, but notice the reading enjoyment scores were a lot lower when they used the 6-inch screen. Maybe this is enough of a difference that the 6-inch screen condition will be significantly different from the 10-inch condition and 12-inch condition. We can't tell by eyeballing the figure like this, but we will know when we do the significance test and look at indices of effect size. So let's continue on page, whoops, I went back to where I was. Let's go back to my figure. Okay. I am still on page 26. Let's scroll down to the bottom of page 26. And we have a table that illustrates in tabular form the same means we just looked at. Same means are presented in this table, headed estimated marginal means. The specific mean enjoyment score displayed by the 6-inch when they're in the 6-inch condition was 40.50. When they're in the 10-inch condition, 58.20, and so forth. So we have seen the general trend of the results. It's encouraging. It's not perfect, but it is at least to some extent supportive of our original research hypothesis. Our original research hypothesis was basically the bigger the screen, the higher the reading enjoyment scores. Let's continue and see what the statistical results do tell us. I'm on page 27 now. Page 27 in the section. At this point, we don't know whether the differences between any of the means are significant. But at least the general trend is consistent with our research hypothesis, which brings us to the section headed Omnibus Statistical Null Hypothesis. In the current context, the word omnibus means overall. So the omnibus statistical null hypothesis for a one-way ANOVA will be a prediction that the independent variable has no overall effect on the dependent variable. We therefore stated the omnibus statistical null hypothesis for the current investigation as follows. Null hypothesis. Mu 6-inch is equal to mu 10-inch is equal to mu 12-inch. In the population, there's no difference between the 6-inch screen condition, the 10-inch screen condition, and the 12-inch screen condition with respect to mean scores on the criterion variable, which is reading enjoyment. Remember, a researcher just about always hopes to reject a null hypothesis. So we hope when we look at our statistical results, we'll be able to reject this statistical null hypothesis. Scroll down on the same page. This is where things get tedious. You may recall me saying in the previous video that the reason I'm dividing this topic of one way within subjects ANOVA across two different units is because a one way within subjects ANOVA involves multiple steps. It's not intellectually challenging, but there's multiple steps you have to go through and multiple decisions you have to make. And this section pertains to one of those important decisions, choosing the appropriate omnibus F-test. At the time of this writing, Jamovi allows us to request 3 different statistical procedures to test the omnibus statistical null hypothesis. They are the unadjusted univariate F-test, the adjusted univariate F-test computed with the Greenhouse-Geyser correction, and the adjusted F-test computed with the Hun-Felt correction. In a given investigation, we will use just one of these three tests. The choice will be determined in large part by the extent to which our data satisfy a fairly complex statistical assumption called sphericity. To determine the extent to which this assumption is satisfied, Navarro and Foxcroft recommend reviewing Mauchly's test of sphericity and the greenhouse geyser epsilon statistic, represented by the Greek letter epsilon. Scroll down a bit. I'm on page 28 now. This is to refresh our memory. Back when we did the analysis, one of the sections of the analysis options panel was headed Assumptions Check. And at that time, we checked a box headed Sphericity Test. That directs Jamovi, I want you to give me statistical tests that tell me whether I satisfy the assumption of sphericity. And there's also a section headed Sphericity Corrections. We checked none at that time because I had known ahead of time that our data would satisfy the assumption of sphericity. And when it satisfies that assumption, you don't need any corrections, and therefore I checked none. If it had not satisfied the assumption of sphericity and we saw an epsilon statistic of one size, we would have checked this to give us the greenhouse geyser correction. And if it had not satisfied the assumption of sphericity and we saw an epsilon statistic of a different size, we would have instead checked this box to get the Hunfeld correction. More about that in a second. Let's keep moving forward. I am toward the bottom of page 28. We come to a section headed Sphericity Test provided by Jamovi. Preceding requests produced the table headed Test of Sphericity in the Jamovi results panel. That table is presented below. The column headed Mauchly's W, which I've identified with callout number 1, Mauchly's W, provides the W statistic, which tests the null hypothesis that the current sample of data was drawn from population that displays sphericity. The column headed P in this location provides the obtained probability value for that statistic. Let's continue. Column headed Greenhouse Geyser contains the obtained value of the greenhouse geyser epsilon statistic. That is below the call out 3. There's our greenhouse geyser epsilon statistic. When epsilon is equal to 1, it means the data displays sphericity. And when the epsilon is less than 1, it means the data depart from sphericity. Lower the value, the greater the departure from sphericity. To keep things simple, this chapter follows the strategy recommended by Navarro and Foxcroft. Here's the recommended approach. If the obtained p-value for Mauchly's test is greater than 0.05, assume that your data satisfy the assumption of sphericity. This outcome means you should report the unadjusted f-test. This is the f-test requested by selecting none in the Jamovi assumptions check panel. And remember, that in fact is what I checked because I knew what the results were going to be. We continue with possibilities. If the obtained p-value for Mauchly's test is less than 0.05, assume that your data violate the assumption of sphericity. In this case, review the obtained value of the greenhouse geyser epsilon statistic. And if the greenhouse geyser epsilon statistic is greater than 0.75, report the f-test with the Hunfeld sphericity correction. This is the f-test that could be requested by selecting Hunfeld in the assumptions panel. So if we had seen results like that, we would have checked this box and get the Hunfeld correction. And continuing with those bullet points. On the other hand, if your obtained p-value for Mauchly's test is less than 0.05, and the greenhouse geyser estimate is less than 0.75, report the f-test with the greenhouse geyser sphericity correction. This is the one requested by selecting greenhouse geyser in the assumption checks panel. We would have checked this middle box to request the greenhouse geyser correction. Now notice I have checked none. We will see the reasons for this in a second. Going back to the bottom, toward the bottom, page 29. In our current analysis, the table headed test of sphericity presented earlier indicated that the obtained probability value for Mauchly's test was 0.244. This p-value is larger than the standard criterion of 0.05, indicating Mauchly's test was statistically non-significant. According to the recommendations suggested by Navarro and Foxcroft, we can interpret this as evidence that the assumption of sphericity has been satisfied. This indicates that we can interpret the unadjusted F-test from the ANOVA, as will be demonstrated in an upcoming section. Now, what was he talking about? We go to the results of the assumptions check request. The table headed assumptions. Mauchly's W statistic for our analysis was 0.70. The p-value for Mauchly's test was 0.244, and this is the key. This is bigger than 0.05, and therefore it's non-significant. Mauchly's W test was statistically non-significant. Therefore, we're going to assume that our data display sphericity, and we are going to go with the results that involve no correction for failing to satisfy sphericity. That is why we made the decision to check none. Now, if you're doing this in the real world, this is obviously a two-step process. You'll do it at least once in order to find out what Mauchly's W statistic is and whether the p-value is significant. And based on that, you'll request the statistical procedure that's appropriate. Let's continue. I'm on page 30 now. Here we have results from the repeated measures ANOVA. And at the bottom of page 30, we have a section that begins results from the omnibus significance test. In the preceding section, we decided that the F-test that's most appropriate for our data set is the unadjusted F-test. We requested this when we checked the box none in the assumptions panel. The ANOVA summary table created by this request is presented below. Oh, that's right. The table that we are going to refer to is this table. The table I mentioned a second ago has all possible corrections reported in one table. Don't look at this. I intentionally decided not to include this in the video because it's a lot of information coming at you all at once, and to keep things streamlined, we're not going to look at this table that gives us all possible analyses. We're instead going to focus on the table that appears at the top of page 31, the one-headed repeated measures ANOVA. This is the results of the within subjects ANOVA that involves no corrections for problems with sphericity. All right, and it's actually, you can see it's actually divided into two tables. We have one table headed within subjects effects and one table headed between subjects effects. The text says, preceding output table consists of two tables. Table headed within subject effects provides results related to our studies within subjects independent variable screen size. So this top table is the one that we're primarily going to focus on in interpreting the results of our omnibus null hypothesis significance test. I'm toward the bottom, page 31 now. Reporting results from the omnibus significance test in text. Let's begin by showing an excerpt from our research manuscript that reports the most important information from the output table. As you know, a lot of times I like to begin at the end. I begin with the way you would write up your results in correct APA style, and then I work backward to see where those results came from. So my summary says, the ANOVA revealed statistically significant effect for screen size. F statistic with 2 and 18 degrees of freedom was 10.66. Mean square error was 122.75. P is less than 0.001. And yes, we will interpret each component of this result. Null hypothesis is tested by computing an F statistic and its corresponding probability value. That's what we have here. And the same statistics are diagrammed below. I took just this portion of the sentence and diagrammed it here at the top of page 32. It's the same results. F statistic with 218 degrees of freedom is 10.66. Mean square error is 122.75. The obtained p-value is less than 0.01. Each of these results, each preceding statistics, appeared in the ANOVA summary table, which is once again reproduced below. This is the same top table that I showed you a second ago, and I've added callouts so that we know what we're looking at. I'm on page 32, toward the middle of page 32. The excerpt begins with a symbol for the test statistic and uppercase F in italics. So yes, when I diagram the results, it begins with my symbol for the F statistic. It's followed by two values within parentheses. These two values, 2 and 18, are degrees of freedom for the F test. These values appear in the Jamovi ANOVA table below the heading DF for degrees freedom. My callout number 1, here's the column headed DF that has my degrees of freedom. Top number is degrees of freedom for the numerator, which in this case is screen size or independent variable. The bottom number is degrees freedom for the denominator, which is 18. And that's why we have degrees freedom are 2 and 18 in our write-up. Let's continue at the bottom of page 32. The obtained F statistic appears in the Jamovi ANOVA table below the heading F. Yes, okay. Now call out number 4 below the heading F. The F statistic is 10.66. Is that what I reported in my diagram section of the sentence? Sure enough, the obtained F statistic was 10.66. Mean square error. It's always good form to provide the estimate of error in your analysis, and that's going to be a mean square error when you do analysis of variance. In the preceding excerpt, MSE represents mean square error. This statistic appears at the location where the column-headed mean square intersects with the row-headed residual. The value should be 122.75. Is that true? Column-headed mean square, the row-headed residual. Mean square error is 122.75. Is that what I reported in my sentence? Yes, mean square error is 122.75. Page 33, and this is going to be the thing that you are going to look at first when you do your analysis, and it's going to be the thing that your readers look at first when you summarize your results in a report. And that's going to be the obtained probability value, the p-value. Obtained probability value for the F test appears at the location where the column headed P intersects with the name of our categorical predictive variable, screen size. Table shows the obtained probability value is P is less than 0.01. It's smaller than the alpha criterion we selected, 0.05, so we can reject the omnibus statistical null hypothesis. We can tell the world we have a statistically significant treatment effect. Where did that come from? Below the heading P. Now, below the heading P and to the right of the name of our independent variable, our obtained probability value for this ANOVA, obtained probability value is less than 0.001. That's smaller than 0.05, and that means we've got statistically significant results. Where does it go in the diagram part of our sentence? At the very end, P is less than 0.001. That is the most important results related to our omnibus statistical null hypothesis. We're able to reject that statistical null hypothesis. We have significant results. You have heard me say, I'm on page 33 now, toward the bottom, page 33. You have heard me say, statistical significance is worth reporting, but it's just one of the big three results. The big three results are statistical significance, confidence intervals, and effect size. So we've got the statistical significance for the treatment effect. What about effect size? At the bottom, page 33, we come to the section that discusses that, omnibus index of effect size. Earlier section indicated that an omnibus index of effect size is a statistic that reflects overall strength of the relationship between the categorical predictor variable and the quantitative criterion variable. For our analysis, we chose to report an omnibus index of effect size called partial eta squared, represented by the symbol. This is the Greek letter eta. This statistic represents proportion of variance and dependent variable accounted for by the categorical predictor variable. Now, in some kinds of analyses, the definition for it is a little bit more complex than that, but that's good enough definition for our purposes. Below is the way that we might report this statistic in the manuscript. Partial eta squared was used as the omnibus index of effect size. The obtained value was 0.54. This represented a large effect according to Cohen's criteria, in which 0.01 represents a small effect, 0.06 represents a medium effect, and 0.14 represents a large effect. Yeah, notice these criteria are different from some of the other indices of effect size we've used this semester. These criteria are different, for example, compared to the criteria for interpreting Cohen's D statistic. D is indifferent, so get accustomed to that. We have different criteria depending on which statistic we're looking at. Also at the bottom, page 33. In the ANOVA summary table created by Jamofi, this statistic appears at the location where the column headed partial eta squared intersects with the row headed with the name of our predictor variable screen size. And it looks like I got to go up to see that. On page 32, where we have our table of results, sure enough, here's the column headed partial eta squared. And to the right of the heading screen size, we see partial eta squared is 0.54. That is a big whopping index of effect size. Okay, pause. You have heard me say, with respect to other types of ANOVA, between subjects ANOVA, if your F statistic is significant and you have 3 or more treatment conditions, if the F statistic is significant, it means that at least 2 of the treatment condition means must be different from one another, but you don't know which 2. The F statistic by itself can't tell you which 2. To determine that, you need to look at a different kind of statistical result. Those results are the focused comparison significance test. So at the top of page 34, we have the section headed Focused Comparison Significance Tests, post hoc tests in this case. Now, this is something you need to worry about only if you have 3 or more treatment conditions. If you only had 2 treatment conditions, you don't need this because we only have 2 treatment conditions and F is significant, then you know which 2 conditions are significantly different. You need this only if you have 3 or more treatment conditions. So let us continue. I'm at the bottom of page 34, and we have a section that represents an excerpt from the research article in which we summarize our results related to these post hoc tests. Let's position this so that we can see the text and the figure at the same time. Figure 1 shows that mean reading enjoyment score obtained in the 12-inch screen condition, and here I provide means and standard deviations, was higher than the mean for the 10-inch condition, which in turn was higher than the mean for the 6-inch condition. Bonferroni procedure was used this post hoc test to investigate the nature of the difference between these means. With alpha set at 0.05, Bonferroni procedure showed that the difference between the 12-inch condition versus the 10-inch condition was not statistically significant, but the difference between the 12-inch condition versus the 6-inch condition was statistically significant. P is equal to 0.021, as was the difference between the 10-inch versus the 6-inch condition. P is equal to 0.008. Now, where exactly did that come from? We haven't seen those results yet. It actually comes from different tables produced by Jamofi. I'm at the top of page 35 now. First, let's begin with those means and standard deviations that I reported in that paragraph. These means and standard deviations were taken from the results of the Jamofi descriptives procedure described earlier in this chapter. For convenience, the relevant portion of that output is reproduced below. This was the descriptives table that we created last week when we did the analysis. You'll recall that in a descriptives table, below the heading descriptives, we have the names of the different statistics being reported. And what do we have here? These columns provide statistics for the criterion variable, reading enjoyment, obtained under each of the three conditions. So when people were using the 6-inch screen, mean reading enjoyment score was 40.50. When they used the 10-inch screen, it was 52.20, and so forth. And to the right of the heading standard deviations, we have those standard deviations that appear in the preceding excerpt. Standard deviation for the 6-inch screen condition was 17.39, and so forth. Again, what am I talking about? I'm talking about this, where I reported the mean and the standard deviation for the 12-inch screen condition here, mean and the standard deviation for the 10-inch screen condition here, and so forth. That is where I obtained those means and standard deviations from my descriptives table created last week. Let's continue. I'm on the bottom of page 35 now. Last two sentences of the preceding excerpt describe the results of the focus comparison significance test we had requested in the post hoc test panel of the Jamovi repeated measures ANOVA procedure. The results of that procedure are presented below. You will recall last week when we used Jamovi to do the analysis of variance, one section of the analysis options panel was the post hoc tests section, and we requested these post hoc tests. Was that panel actually headed post hoc tests? Let's make sure that I'm using the correct terms. Yep, sure enough. From last week, page 22 last week, one part of the analysis options panel was headed post hoc tests. We revealed it here, and in this section I told you exactly how to request the post hoc tests we want. Let's go back to where we were. I'm on the bottom of page 35, and this is the section I just read. Last two sentences of the preceding excerpt describe the results of the focus comparison significance test we had requested in the post hoc test panel of the Jamovi repeated measures ANOVA procedure. Results are presented below. And on the top of page 36, we have the post hoc test table produced by Jamovi. The good news is this table is laid out the same way the post hoc test table was laid out back when we did one-way ANOVA with one between subjects factor. Here I have added call-out numbers, and in the text below I explain where you look in this table to find specific results. First section of the table is headed comparison, and the labels below this heading identify the two conditions being compared for a given test. So below the heading comparison, we can see the first row of the table involves the comparison between the mean score displayed in the 6-inch condition versus the mean score displayed in the 10-inch condition. Results for that comparison are going to be in this top row, which is what the next bullet point says. First row of the table is headed 6-inch minus 10-inch, indicating this row provides information about the difference between 6-inch condition versus 10-inch condition. The column headed mean difference provides the difference score obtained when the mean for one condition is subtracted from the mean of the other condition. First value in this column is negative 17.70. This indicates that when the mean enjoyment score obtained under the 10-inch condition was subtracted from the mean obtained under the 6-inch condition, it produced the mean difference score of negative 17.70. So here, under mean difference, for the first row, it's negative 17.70. Now that's the mean difference, but wait a minute. How do you know that this is the mean difference you get when you subtract the 10-inch condition from the 6-inch condition? Why isn't it possible that this is the difference you get when you subtract the 6-inch condition from the 10-inch condition? You know, because of the heading under comparison. It specifically says 6-inch minus 10 inch gives you this negative 17.70. So do take this as a subtraction. What is being subtracted from what? Let's continue with my bullet points. The column headed P Bonferroni provides obtained probability value, that is p-value, for the Bonferroni post hoc test. Table shows that the p-value for the difference between the 6-inch condition versus the 10-inch condition was p is equal to 0.008. This obtained p-value is smaller than our alpha criterion of 0.05, so we reject the null hypothesis. In other words, we conclude the difference between the two conditions is statistically significant. Oh, where did that come from exactly? Oh, it's here. The column that's headed P Bonferroni. If you're wondering how come it has P with Bonferroni as the subscript, theoretically, we could have requested additional post hoc tests. We could have requested a Tukey post hoc test here, in which case there would be another column headed P. It would be P with a Tukey as a subscript. But we requested only the Bonferroni post hoc test. So in this column, first entry is 0.008. So that means that the difference between the 6-inch condition versus the 10-inch condition is statistically significant. We know it because this p-value is 0.008 and it's smaller than 0.05. That means significant difference. We continue. Is there any more yellow type? There's no more yellow type, but let's just make sure that everybody understands what is and is not significant here. When we look at this post hoc test table at the top of page 36, as was the case back when we did one-way ANOVA with one between subject factor, the two columns you're going to be most interested in are the column headed mean difference and the column headed P Bonferroni. Difference between the 6-inch and 10-inch condition was negative 17.70, a difference that was significant. The difference between the 6-inch versus 12-inch condition was negative 21.40. That p-value is 0.021, but look, that's smaller than 0.05. So yes, this difference is significant as well, the difference between the 6-inch and 12-inch condition. Finally, last comparison, difference between 10-inch versus the 12-inch condition. The p-value is 1.0, and yes, that's a lot bigger than 0.05. That means that's non-significant. So two of our differences are significant. One of them is not. Let's take a look at that figure again and see that this does make sense. Here are the two means that were not significantly different from one another. And it makes sense, doesn't it? There's hardly any difference between these two means. But the difference between the 6-inch versus 10-inch condition were significant. Difference between the 6-inch versus 12-inch condition were also significant. So those post hoc test results do make sense given the nature of the figure that we've just reviewed. Next, we come complete summary of the results from the research manuscript, where I kind of put everything all together in one summary. We come to a checklist reporting ANOVA with one within subject factor, all the things you need to worry about, all the things that you need to include. And on page 39, we come to this. Page 39, a red font box. Now, complete your work on Jamovi exercise 120.01 ANOVA with one within factor. For today, you'll complete task 2, taking the multiple choice quiz, and task 3, uploading your Jamovi file in Canvas assignments. Remember, last week, you basically didn't have to submit anything. You didn't have to take the multiple choice quiz or upload anything. This week, you will. You will upload the Jamovi file that you created last week, and you'll take the multiple choice quiz to demonstrate that you understand the results there and you're able to write it up in correct APA style. As always, I recommend take the quiz first. That'll be a way of ensuring that you did your analyses correctly. And once you've taken the quiz, then upload your file. I have another box below that says you don't need to complete the activities described in this chapter appendix below. It simply provided so that students will have instructions for creating data set from scratch if they want to conduct a within subjects experiment in the future. So which set of lecture notes has this been about? This has been Lecture Notes, Chapter 120, ANOVA with one within subject factor.